Good day, class. In this lesson, we will study limits. I like to think of limits as a means of defining derivatives and think of derivatives as a means of defining limits. Let's take a look. So I want you to really understand what we mean when we're talking about limits. So I'm going to take some time to just sort of unfold it for you. If you'll just be patient, two of the primary concepts we study when we learn calculus or we learn the field of mathematics known as calculus is to study derivatives and integrals. Well, derivatives can be defined by the term limits, and integrals can also be defined by the term limit. So notice how limits describe a number which an approximation is approaching. So I'm going to take some time to describe how we're approaching the red point that you see on the derivatives graph and how we're approaching the space, the measure of the space that you see that I'm trying to analyze under the red curve on the integrals graph. So let's take some time to understand what's going on here. First, we'll talk about limits. Notice here how limits, I'm using limits to define a derivative. So notice here on the graph, I have a point, 1.7 on the x-axis and 1.597 on the y-axis. This is a location in space. And notice how I've also described this location in space on my chart on the right-hand side. So let's discuss moving and approaching that point, 1.7 on the x-axis, 1.597 on the y-axis. So what I'm going to do is just any arbitrary point. Notice how I'm just going to pick some other point. I'm out to 2.2 on the x-axis and 1.56 on the y-axis. Now I'm going to let that new point approach my old point. And notice how I'm describing this as x is approaching 1.7 from the right. I'm calling this from the right because that new point 2.2 1.56 is on the right hand side of my original point. And so I'm going to move in closer, and in each occasion I'm going to describe my change in x and my change in y. So notice how the difference in my x values, that 1.7 and 2.2, if I subtract those, I'm going to get negative 0.5, and if I subtract my y values, I'm going to get 0.037. This is my change in x and my change of y. And remember how you describe slope. You just divide your change in y by your change in x. So the slope of this line is a negative slope, negative 0.074. No surprise, the red line has a negative slope. Okay. Moving right along, I'm going to get closer. So I'm choosing a new point that is closer to my original point. And I'm also going to take some time to describe this, the change in x, my change in y, and then I'm going to calculate the slope. Okay, so nothing new has happened here. I'm just moving my point closer because I'm trying to describe what is happening. Also notice how I have a secant line here. Forgive me, I forgot to mention that in the previous slide. This is a secant line. It's touching the curve, it's crossing the curve in 2 points. And it remains a secant line crossing a curve at 2 points because if I move it just slightly, I still have a secant line. So I'm going to move this slightly a little bit further. Notice what's happening to the slopes. Okay, so that slope, notice what's happening to the steepness of the slope. Okay, and so I calculate again. I move closer. I still have a secant line. I'm still crossing this blue curve. My red line is crossing the blue curve in 2 places. And it's still a secant line because it's crossing the curve in exactly 2 points. And if I shift even a little bit further, notice what's happening. I'm getting closer and closer and closer. Now my slopes aren't really changing that much. The change is starting to sort of fall off, level out, and I can continue to get closer and closer to my original point. And I can get infinitely closer if you sort of embrace that term infinite. I can get infinitely closer. Now, obviously, I can't sketch the lines here that get infinitely closer, but I can effectively get infinitely closer to this original point. And notice that slope continues to get it continues to approach a number. This is what we mean by the limit. What is the limit of approaching? How close can I get before I just reach a point where I just can't get further? Notice how X is approaching 1.7 from the right. Notice my red above the chart. I'm using some vocabulary here. I'm sort of describing that vocabulary to you. X is approaching 1.7 from the right. In our notation, we just sort of put a positive symbol right there to the upper right corner of our number, and that actually reads X is approaching 1.7 from the right. So I continue to get closer. Again, I could do this to infinity, getting closer and closer, but we already see what's happening to the slopes of the line. It's really not changing that much, to the point where am I going to reach a limit? And that is what we describe as the limit. This number is approaching 0.09, or the slope of this line is approaching 0.09. And notice how suddenly I no longer have a secant line. The instant I now have a tangent line, this slope of this tangent line is describing the limit of this function at this very point, 1.7, approaching from the right. Now, here is where we must go a little further. I'm reaching the limit of approximation. A lot of things have happened suddenly. When I reach that limit, I now no longer have a secant line. Instantly, I have a tangent line. However, there is another caveat to defining limits regarding this curve. Notice here, I really want to emphasize notation. On the left, I'm describing the limit of a function as x approaches 1.7 from the left. And then on the right hand side, I'm using notation to describe the limit of a function as x approaches 1.7 from the right. So we just took care of the right hand side. We approached, you saw graphically how we were able to approach the limit from the right. Let's look at how we approach the limit from the left. Now notice my original point is the same, 1.7, 1.597. I'm going to pick some arbitrary point on the left, and I'm going to start approaching my original point. I now have a secant line. This secant line is only going to become a tangent line in one instant, when I just barely move that line and it becomes a tangent line. So right now it's a secant line. I can measure the change in x, the change in y, and calculate the slope. I'll do that again. I'll get closer. I'll continue to get closer and closer and closer. I still have a secant line all the time. I'm coming in from the left. X approaches 1.7 from the left. Notice my notation with my negative in the superscript after my 1.7. So that X value is I'm now down to 1.4. I'm going to continue to get closer and closer, and I'm going to observe what's happening to that slope. It's getting closer and closer to what number? This is my limit. Now, as you'll notice, I'm getting closer and closer, and then maybe you will observe at this point, there is going to be a point where I can't get closer because I will become a tangent line. And here I see my limit is approaching 0.09. Again, coming in from the left, I can approach this point. Coming in from the right, I can approach this point. But for this value, 0.09, to be defined as the limit of the curve at this point, 1.7, this has to be the same limit coming in from the left and coming in from the right. So recall that limits describe a number in which an approximation is approaching. Regarding derivatives, we will take another lesson to describe this regarding integrals.